During certain periods, typically in the mornings and evenings, demand for electricity increases rapidly. To keep up with this demand, the dispatched generation must ramp up quickly. In this scenario, thermal generation is dispatched to help meet peak demand. Thermal generation has some particular properties. It can be slow starting out and ramping up. After an unexpected instruction to start, a generator can typically take 10 to 15 minutes to begin generating electricity, and the ramp rate can be limited to 5 megawatts per minute. The dispatch schedule doesn't take the slow start into account. Now we'll see what this means in our scenario where we're ramping up towards the morning peak. When the thermal generator is dispatched on, this initial dispatch instruction in real time may be too late for the generation to start producing electricity at the level needed to keep up with the demand. If the generation is too slow to ramp up to meet their dispatch set point, this may lead to a drop in the system frequency. Generators assigned to frequency keeping may be pushed to their limits to balance the system. To maintain frequency, the system operator may over-dispatch, instructing the next generator in the price stack. If there are no more generators in the price stack, or the generation is constrained, the dispatch engine sacrifices some reserves to balance the system. This results in a reserve shortfall and a negative impact on system security. To avoid this situation happening in real time, the system operator can use discretion to dispatch slow starting generation earlier. This allows time for the generator to start and to ramp up to keep up with the demand. This means avoiding a reserve shortfall and system security is maintained. Let's look at how applying discretion in this scenario may impact the market. Here's the price stack, with the various generators and their offers. This shows the demand and the resulting marginal price. When discretion is applied to dispatch the slow starting generation earlier, it moves to the bottom of the price stack. This may lower the marginal price, while the generator that was dispatched out of merit will be paid constrained on costs. In this scenario, by applying the discretion, the system operator aims to ensure that the slow starting generator is already connected to the system before it is required. This allows them to maintain the primary objective of running a secure power system by keeping generation and demand in balance and avoiding a reserve shortfall.